So in this class, we will discuss some problems, examination problems. It is from the question paper June 2016 video question paper. The figure shows a cantilever beam with two forces and a couple. Determine the resultant of the system and also an equivalent system through point A. So this is the cantilever beam given. You know that in the case of the cantilever beam, one end is fixed end and the other end is a free end. Here A is the fixed end, B is the free end. So reactions will develop, support reactions will develop only at the fixed end. Here if you observe the beam, only vertical forces are given. One 4 kN force downward at C and 2.5 kN upward force at B. There is no inclined force or horizontal force. Therefore, reaction at A will be, you will be having vertical reaction at A, which I can call it as VA. VA is the vertical reaction at A because only vertical forces are acting on the beam. And also it develops a moment. So that moment I will take it as MA. Because it's a fixed end, generally you have three reactions at the fixed end: horizontal, vertical, and inclined moment. But here, since there is no horizontal force or inclined force acting on the beam, so only vertical reaction and moment will be developed. So first step, of course, here, okay, this is a resultant problem. So you need not compute the reactions. Of course, later on at the end, I will calculate the reaction also. It is not asked here. Here he has asked the resultant force and equivalent system to the point A. Now let us calculate the resultant force. This given system of forces, it is a coplanar non-concurrent force system. Coplanar non-concurrent. So in the case of coplanar non-concurrent force systems, so the resultant reaction R is given by, resultant R is given by sigma fx square plus sigma fy square under root. So where sigma fx is the algebraic sum of the forces in x direction and sigma fy is the algebraic sum of the forces in y direction. So I will take this as x direction and this as y direction. So if the force is acting in the opposite direction, then it is taken as negative. And you have this is the magnitude of the resultant. Direction of the resultant is given by alpha, that is tan inverse of modulus sigma fy by sigma fx. So this is what we can make use. And also in the case of non-concurrent force system, we need to compute the position of the resultant also. Position of R or the location of R, which is given by d is equal to, we have to take the algebraic sum of the moments at about any point. I will take that as sigma ma divided by the resultant R. So modulus of that gives the position of R, that is the perpendicular distance of the line of action of resultant from the point A. It is taken like this. So position of R from point A. Yes, these are the formula we have to use now. Now, first let us find out sigma fx. Sigma fx is found out by using the sign convention. Forces acting towards right side positive. I have taken x axis like this, y axis like this, positive directions. So, if you observe, there is no horizontal component or horizontal force acting on the beam. Therefore, sigma fx is 0 here. Sigma fy, so I will take forces acting upwards positive, downward negative. So upward force is 2.5 kN, this I will take as positive. Downward force is 4 kN. So we are getting minus 1.5 kN. Minus stands that the vertical sigma fy is acting downwards. So when you are calculating sigma fx and sigma fy, you need not take the external moment of the couple given on the beam. Now you can find out the resultant reaction now. R is found according to this formula, square root of sigma fx square plus sigma fy square. Since sigma fx is 0, so R will be equal to sigma fy only. Of course, you can take sigma fy square under root, because sigma fx is 0. So modulus is always positive, so it comes out to be 1.5 kilonewton only, and of course it acts downward. That means since sigma fx is 0, resultant is nothing but sigma fy only. So this negative sign indicates that it is acting downward. So this is the magnitude of R. Magnitude is always positive, therefore I neglect the negative sign. So 1.5 kilonewton is the magnitude of R. Now direction of R, it is not required because we know that it is acting vertically downwards. Now only thing is we have to find out the position of R. So position of R, so we have to assume. So since the direction is acting downwards, let us calculate the position with respect to point O. So to find the position with respect to point O, position of the resultant with respect to point O, I will calculate sigma MA. So sigma MA is nothing but the algebraic sum of the moments of all the forces taken about the point A. So there are two forces and one external couple is given. So for this the sign convention I will take clockwise positive, anti-clockwise negative. Now I am here. So the moment of 4 kilonewton about the point A is clockwise. So it will be 4 into 1. So moment is defined as magnitude of the force multiplied by the perpendicular distance from the point under consideration to the line of action of the force. So 4 into 1, which is positive. So 4 into 1 is positive because it is clockwise. Then this 2.5 into 2.5, because 1 plus 0.8 plus 0.8 is 2.5. It is anti-clockwise. So minus 2.5 into distance is also 2.5. So this is anti-clockwise moment. Now this external component is given, external moment is given on the beam, that we have to take directly the magnitude of that couple. We should not multiply by the distance. So that means it is 2 kilonewton meter. It is clockwise, therefore it is plus 2. That's all. You should not multiply by the distance because the effect of the couple of the moment will be same wherever it acts on the beam. So now if you simplify this, so this is 4 minus 2.5 into 2.5 or 2.5 square plus 2. So it comes out to be minus 0.25. Minus 0.25 kilonewton meter. So because it is moment, so since this minus indicates that it is anti-clockwise. It is anti-clockwise because I have taken clockwise as positive. Now I want the distance of this from the point A. Now I will calculate the distance. So distance of the resultant force, line of action of the resultant force from the point A, D is given by sigma MA by R modulus, which is 0.25 divided by, so since it is modulus, we have to take the positive value, divided by the value of R is 1.5. So 0.25 divided by 1.5, that is the value of D. So it comes out to be 0.166, that is 0.167 meters from A. So I have taken the position from the point A, 1.167 meters. That means now we have to check whether that resultant acts to the right of A or left of A. That is very important. Since the moment is anti-clockwise, so we have to see. So it is acting at a distance of 0.167 means somewhere here or here. From the point A, because the resultant is acting downwards, either it should be right of A or left of A at a distance of 0.167 meter. Since that resultant is giving an anti-clockwise moment, or sigma MA is anti-clockwise. So what I have to take here is, if I take here downward, it is giving a clockwise moment. So if I take here, it gives an anti-clockwise moment. That means the resultant force is acting here. So you have to understand this concept. Resultant force is acting here. This value is 1.5 kilonewton, and this distance from here to here, from the point A to the resultant force is D, that is 0.167 meter. So this is how we have to get. So you will be having two possibilities. Since the value is negative and it is giving an anti-clockwise moment, sigma NA is anti-clockwise, this resultant should give an anti-clockwise moment about A. Suppose we get positive value there, it should give clockwise, that means it's already here. So that is how we have to take. Now this is the position. So what you can say is the resultant force is acting at a distance of 0.167 meter from the point A to the left side of A, and it is acting downwards. So this is the conclusion for the first part. Next, for the second one, we have to determine an equivalent system. So force couple system. So this is first part. We have found out the resultant. Second part, we have to transfer this resultant force to the point A. So that means it is called as equivalent force couple system. I have done some problems on this also in the earlier videos. You can refer that. Equivalent force couple system at the point A. Now it is acting at some other point here. Maybe I will take this as E. So the resultant is acting at E. Now I have to transfer this resultant force acting at E to force couple system acting at E. So for that, what we have to do here is, this is R. We have got 1.5 km, and it is acting at a distance of 0.167 meter, like this. Now I want to transfer this over here. So I have told you that whenever you want to transfer this force to here, what we are doing is, we are going to introduce the same force here at the point in the same direction, that is 1.5 kN force is transferred to the point A. In addition to that, we have to take the anti-clockwise moment, because this R is giving an anti-clockwise moment about A like this, MA value, which is 0.25 kN. So that means this is how we can transfer a force acting at one point to a force couple system acting at some other point. So this is the answer. So the effect of this 1.5 kN acting at E is the same as the combined effect of 1.5 kN force acting at A and also the anti-clockwise moment at A. So this is how the equivalent system through A is obtained. So we have to, like this, we have to solve the problem. The second question from the same question paper. So let me write down the problem now. The second problem. So here a vertical mast is there. This is the ground level. A vertical mast is there here. Okay, this is AC. Vertical mast is AC. It supports two cables with tension force of 3 kN and 7 kN, like this. So it supports like this. Two cables. So these are the cables. In the first cable, you have 3 kN force, tension force. Tension force means it is acting away from the point C. Second cable, it is 7 kN. Of course, he has given the angles 10 degree and 25 degree. So this is 10 degree and this is 25 degree. He has given that. So, and what is the essence is, BC is a gay wire. So there is one more wire here. BC is a gay wire. This is called as a gay wire, which also carries tension force at a distance x from the mast base. So this is the mast. So from the base, this distance is x. So this is the mast. Vertical mast. He has given like this. The resultant of the force system is limited to 12 kN maximum, and it acts vertically down the mast. So that means the resultant force is given like this. So this is the resultant force. Maximum value of resultant force is 12 kilonewton. Of course, in this guide wire also you will be having tension force like this. T. T is the tension force. Tension force always you have to show acting away from the point. So from the point B it is acting away, from the point C also it is acting away. Now the question is find the distance x, and this height of this mast is 50 meters. So this here is given it as 50 meters. Now the question here is what is the value of x? Of course x is also not known, t is also not known here. Both are not known. So we will calculate those values now. So this is the given problem. This angle, of course, we have taken it as theta. Theta is the angle. Now, to do this problem, since resultant is known here and all the forces are meeting at this common point C, it is the case of a coplanar concurrent force system. Coplanar concurrent force system. So I will write here. So coplanar concurrent force system. So here, in this case, you have the equation for the resultant as magnitude is given by sigma fx square plus sigma fy square and the root. And of course, angle made by the resultant will be horizontal. Alpha is tan inverse of sigma fy by sigma fx. Of course, here there is no need to find the position because the resultant also passes through the point of concurrence C here. So now let us use the same concept what we did in the last problem. Let us calculate sigma fx and sigma fy. So these are the these three forces I have to take. The resultant is acting vertically downwards. So sigma fx I will take forces acting towards right positive, that is the sign convention. So we have to resolve these forces now. 3 kilonewton force I have to resolve. Then I have to resolve the 7 kilonewton force also. With respect to the horizontal, this is 10 degree. This is 10 plus 25, 35 degrees. Now if you resolve these two forces, so for this resolution is like this and like this. For this it is like this and like this. These are the components of those two forces. Now this is 3 cos 10. This is 3 sin 10. And this is 7 cos 35. This is 7 sin 35. In addition to that, we have to take this tension force T also, which is not known. So that tension force T is acting at an angle of theta with the vertical. That is what he has given here at the junction C. Now if you resolve this, so what happens here, like this we have to resolve. This is in the third quadrant. So this will be T cos theta because this is the adjacent angle. This will be T sin theta. Now these are the three forces acting at the point C. Of course, R is the resultant. Now let us find out sigma fx for this. So I have taken forces acting towards right positive. So 3 cos 10 degrees is positive plus 7 cos 35. Now this is minus T sin theta. So this is what sigma fx is. And next sigma fy. Of course, this I can simplify. 3 cos 10 is 3 into cos 10 plus 7 into cos 35 is equal to, you will be getting 8.688. 8.688 minus T sin theta. So this is sigma fx. I call this as equation 1. Now sigma fy. So for finding sigma fy, sign convention is upward force positive, downward force negative. So if you observe here, this is negative, this is negative, this is also negative. So minus 3 sin 10 minus 7 sin 35 minus T cos theta. If you simplify this one now, so you will be getting 3 into sin 10 plus 7 into sin 35. It will be minus 4.536 minus 4.536 minus t cos theta will be. So this is equation. Now we got the values of sigma fx and sigma fy. Now since the resultant direction is known, it is acting vertically downwards. So the value of the sigma fy itself is your r, similar to this example. So sigma fy itself is your r. So in the magnitude. So that is the point we have to keep it in mind. Now we have to equate that r is equal to sigma fy, whereas sigma fx will be 0 because resultant is acting vertically downwards, that is in y direction. There is no x component of the resultant, so sigma fx is 0, sigma fy is r, so which is equal to 12. So after writing those two equations, we can solve. We can solve for the unknowns. Both we can solve for t and theta. Once we get t and theta, then x can be found. So finally we are interested in finding the value of x. So let me do that now. So if you do that, so please check the values once. Yeah. Now let me rub this and continue. So just now solving the equations, that's all, trigonometric equations. So the conditions now available are sigma fx is 0 and sigma fy is equal to r because the resultant is acting along the y direction. So now we have sigma fx is equal to 0, this is first condition. We have sigma fx as 8.688 minus t sin theta, so that should be 0. Minus t sin theta is equal to 0, or I can write t sin theta is equal to 8.688. So this is equation 3, I will write. Then the next condition is sigma fy is equal to r because we have given the resultant acting in the negative y direction. Sigma fy, of course, it is acting downwards. So therefore, if you take this minus 4.536 minus t cos theta is equal to r. So here, one thing you should be careful here. Since this r and sigma fy, they are acting in the same direction, this negative sign. So what I can do here is this negative sign indicates that it is acting downwards. That means I have to take like this. Be careful here. Is equal to r. So this negative sign indicates that sigma fy and r both are acting downwards. So therefore, I can take this whenever you are writing the magnitude is 12 kilonewton for r. So instead of writing minus 12, I take as plus 12 and the equation becomes now 4.536 plus t cos theta is equal to 12. Or I can write t cos theta is equal to 12 minus 4.536. So which is 12 minus 4.536, which is 7.464. So like this, we can get the two trigonometric equations in cos and sine, equation 4. Now you can get one equation you have cos theta, another equation you have sin theta in the LHS. So you can easily solve these two equations by dividing. So 3 divided by 4, equation 3 divided by equation 4 gives sin theta by cos theta, t will get cancelled, which is tan theta. LHS divided by LHS is equal to RHS divided by RHS. 8.688 divided by 7.464, which is 8.688 divided by 7.464, 1.164. So therefore theta is equal to tan inverse of 1.164, which you are going to get it as 49.3 degrees. So this is the angle theta. So this angle theta made by the gay wire with the vertical mast is 49.3 degrees, so that the resultant acts vertically downwards. Once you get the value of theta, now tension in the spring can be found out easily. So by substituting, of course he has not asked us that, but anyway we will find out. Substituting for theta in equation 3 or 4, any one of these two equations, you can get T is equal to 8.688 divided by sin theta, that is sin 49.3 degree. So which is, so you can take it as 8.688 divided by sin 49.3 degree, which is 11.46 kilonewton, because the forces are given in kilonewton, tension force also will be in kilonewton. That means in the gay wire, the tension force developed is 11.46 kilonewton, so that the resultant acts vertically downwards. Now he has asked this distance x now. So distance x, of course this is 50 meters. He has given this as 50 meters. Now this angle is known. So we can find out the distance x. So let us see. Now we have got this diagram. This is x, AB, and this is theta. We got now. Theta value is we got it as 49.3 degree. So we know one angle and one length dimension. This is 50 meters. Now by taking, so this is the angle. So by taking the tan theta ratio, you can from this triangle ABC, tan theta is equal to opposite side is x, that is AB, divided by adjacent side is 50 meters. So therefore x is equal to 50 into tan theta. That is 50 into tan of 49.3 degree. So the answer here is 50 into tan of 49.3 degree is equal to 58.13 meters. So the distance AB, x distance, is 58.13 meters. So this is how we have to analyze the problem. Here what the concept is, it is a coplanar concurrent system, and the resultant is given acting vertically downwards. Therefore the condition is sigma Fy will be equal to R, sigma Fx will be 0. There are three forces acting at this joint C. Tension force in the guy wire, 7 kN force and 3 kN force. We have resultant forces. Write down sigma Fx and sigma Fy, equate sigma Fx to 0 and sigma Fy to R, and then solve the trigonometric equations which you are going to get the unknowns T and theta. Then using the trigonometric ratio for this triangle ABC, we can get the value of x. So this is how we have to solve the problem.